So given that point A has position vector 4i minus 7j, and point B has position vector 10i plus qj, where q is a constant, find in part A the vector A to B. So the vector A to B is what we need to find. We've been told that the position vector of A is 4i plus 7j. So the position vector is how I go from the origin to the point A, and that's 4, 7 in column vector form, and we've been given the position vector of B, so O to B is 10i plus qj. And then we've got to find A to B. Now to get from A to B, I'm just going to draw a quick sketch here. Let's just say A is there and B is somewhere around here. To get from A to B, I can go from A to O and then from O to B. So A to O plus O to B. And A to O is going to be the negative version of O to A, so it's going to be minus 4 minus 7 plus O to B, which is 10i plus qj. So that's going to give us 6i and q minus 7j. So that's part A. Given further that the magnitude of A to B is 2 root 13, find two possible values of q showing detailed reasoning in your working. Okay, so we know that the magnitude is 2 root 13, which means the magnitude is calculated by doing the square of the I plus the square of the j component square rooted, and we know that that gives us 2 root 13. Okay, so inside the square root I've got 6 squared, which is 36, plus, and expand this bracket, q squared minus 14q plus 49, and that's all square rooted, is equal to 2 root 13. I'm now going to square both sides. So if I square the right hand side, 2 squared is 4, square root of 13 squared is going to be 13, and simplify this a little bit, so I'm going to get q squared minus 14q plus 85. So 4 times 13 is 52. Let's bring the 52 over. So q squared minus 14q plus 33 equals 0. Now you've got quadratic, which you can factorize. So it's going to be q minus 11, q minus 3 equals 0. And so q equals 11, or q equals 3.